So looking at adding and subtracting square roots here. When we're adding and subtracting square roots, we can use the distributive property somewhat with expressions that have radicals. For example, if we have 3 times the square root of 2 plus 2 times the square root of 2. Well, we can say this is the same as saying 3 plus 2 times the square root of 2, which would be 5 times the square root of 2. Basically, the way I like to explain this is the radicand. When we're adding or subtracting square roots, a couple different things we need to have in mind. We have to have like radicals. And what it means to have like radicals that have the same index, but they also have to have the same radicand. So the index, our index is what power we're going to. In a square root, we don't write second power there because that's the lowest power we will have this symbolization for. But that is the index. The index is what goes here. So if we had the cube root, the index would be 3. If we had the fourth root, the index would be 4. And the radicand means what's under the radical sign. So in a way, we can think of this adding and subtracting radicals a little bit like adding or subtracting fractions, where in fractions we have to have the same denominator. And radicals, we have to have the same radicand and the same index. So they're very, very similar in that sense. Okay? So if we want to combine like radical terms, let's look at a couple, one more example here. Let's say we had the square root of 10 minus 3 times the square root of 10. Well, again, we should be able to understand that nothing in front here is the same as saying 1. So 1 minus 3 is negative 2 times the square root of 10. It's that simple. Now, we can run into problems if we have instances where we don't have the same radicand, because many times it can appear that we can't add these things together. However, we may be able to. So let's say we have an instance where we may have the square root of 50 plus the square root of 8. Well, right now, we can't add those. However, if we simplify these radicals, if we factor out our radicands and rewrite them, we may find that we can add them together. So let's start first with the square root of 50. The square root of 50 is equal to the square root of 2 times the square root of 25. And right there, 25, we have a perfect square. Square root of 25 is 5. So the square root of 50, if we break it down and simplify it, is 5 times the square root of 2. Well, the square root of 8 is equal to the square root of 4 times the square root of 2. We know here the square root of 4 is 2. So we can say this is plus 2 times the square root of 2. And now look what's happened for us. Now we have the same index, we have the same radicand. We can combine these terms. We get 7 square root of 2. So this can be done. We may have to work through our radicals a little bit, but it can happen. So I'm going to look at a couple more examples here in this video, adding or subtracting. I think I'll probably be subtracting since we did some adding already. So the first one we'll have here, let's say 7 times the square root of 12 minus the square root of 75. Well, again, 7 times the square root of 12, we can break the square root of 12 down into the square root of 4 times the square root of 3, and we know the square root of 4 is 2. So the square root of 12 is really 2 times the square root of 3. So we're looking at 7 times 2 times square root of 3 here, minus, well, now we're going to break down the square root of 75. The square root of 75, we can break down the square root of 25 times square root of 3. We already know square root of 25 is 5. So now we're looking at 5 times the square root of 3. So look at 7 times 2 is 14, so we'd have 14 square root of 3 minus 5 square root of 3, which would give us 9 square root of 3. Okay. Do one more subtraction here. And let's do this is a little longer one, but the square root of 25 minus the square root of 27 minus 2 times the square root of 18 minus the square root of 16. Well, let's start looking. We know the square root of 25 is 5. Minus, we have the square root of 9 times the square root of 3. That's the square root of 27. Minus, let's do it like this. 2 times the square root of 18. Well, we know the square root of 18 is 9 times the square root of 2. And then the square root of 16 is 4. So now this is where we're at. So we can go ahead through these and say, okay, now we have 5 minus square root of 9 is 3, so we have 3 square root of 3. We don't need the parentheses anymore here. Now, square root of 9 is 3 times 2 is 6, so it's minus 6 square root of, what we have there, 2 minus 4. So at this point, 5 minus 4 is 1, so we're looking at 1 minus 3 square root of 3 minus 6 square root of 2. This would be the final answer we'd be looking at. This is simplified down as far as we can go with this number of radicals there. So I hope this helped with the adding and subtracting square roots. The next one I'll be doing multiplying and dividing. So have a good day. Bye.